This example shows the details of the multi-resolution matching process. From the current node, the method tries to match a mesh arc to a skeleton arc. Since the local shapes are different, the method goes to finer resolutions. The local shapes are now the same, and the method matches the two arcs and proceeds to the next node. From this node, the method selects the two rightmost arcs since they have the same symmetry markings. Their local shapes are already identical, so there is no need to go to finer resolution. The arcs are matched, and the method proceeds to the next arc. The matching for the left arcs is the same as that of the previous ones. The method then proceeds to the upper arc, which is also directly matched. At the next node, the method goes to coarser resolution levels. In fact, at every new current node, the method goes to the coarsest resolution level where the local shapes are identical. For the previous nodes, there were no such levels, so this step was skipped. From the coarsest level, the method matches the arcs one at a time, selecting arcs with the same symmetry markings. Thus, the right arcs are matched and then the left arcs. Matching is completed. Notice how it used a fine resolution for the lower part of the graph and the coarse resolution for the upper part. This example shows the multi-resolution matching process on a typical character. Here we can see the symmetry tagging. Notice how the method goes to finer resolutions to find the coarsest arc with the correct local shape. Also notice that when moving to a new node, the method goes back to the coarsest resolution level with the correct local shape. This approach matches local shapes using coarse resolution levels. It ensures that the most meaningful resolution level is used for every arc. The method proceeds and both arms and hands are correctly matched. Here is the retargeted skeleton with its position adjusted to match the mesh. The method is also useful to retarget partial skeletons. We first demonstrate the control bones of the original skeleton. The retargeting process is applied by first selecting head nodes on the skeleton and the mesh. We then see that the retargeted bones are correctly placed and that the foot roll, IK, and pull target work exactly as on the original skeleton. This arm skeleton uses IK, pull target, and finger flexors controls. After retargeting, the bones are correctly placed and the control bones work properly. This example shows how skeletons with multi-jointed limbs are correctly retargeted. Notice the proper placement of the legs and antennas. Also notice how the correct bone placement allows for meaningful deformation of the mesh. These results show how the user can control the retargeting process from conforming to the original skeleton to conforming to the input mesh by adjusting two sets of intuitive parameters. This example shows a short animation done with a humanoid skeleton retargeted to a cartoon character. Notice how the retargeted skeleton allows for a fluid animation. Also notice how the feet, hand, and knee controls have been correctly retargeted.